After study this module, you shall be able to know about air pollution and their sources, know about the instruments used for continuously monitoring air quality, learn about the impact of air pollution, learn about the different components of these monitoring instruments and their functions, identify the advantages of several continuous monitoring instruments, evaluate the technology for air pollution control, and analyze the chemistry behind the methods of evaluation. So, first thing is introduction. Air pollution control. Air is said to be polluted if it contains substances in enough concentration to cause harm or undesirable effects. These include adverse effects on human health, property and environment. Atmosphere is susceptible to pollution from natural sources as well as from human activities. Some natural causes such as volcano and forest fire may have long lasting effect of an environment. Combustion process is the main cause of contamination to air. These pollutants include fine particulates, carbon monoxide, sulfur dioxide, nitrogen dioxide, ozones, etc. Most of the pollutants are organic in nature. The efforts should be taken to control these pollutants. Best method to protect the air quality is to reduce the release of pollutants by changing or improving industrial processes. Pollution control equipments are used as a technique of controlling air pollution. Control equipments removes the pollutants and converts it to less harmful contaminants. That results in the recovery of valuable material for further use. The other aspect is removal of suspended particles. Particles can be removed from air by a variety of physical or chemical processes. Some of the common types of equipments are cyclones, scrubbers, electrostatic precipitators and baghouse filters. The collected particulates can be removed from the equipment and disposed in a landfill. The important characteristics of particulates on which the selection of the collection device depends include corrosivity, reactivity, shape, density and especially size and size distribution. The first thing is which we are going to discuss, cyclone. The cyclone collectors are used to control industrial dust emission. They use centrifugal forces for removal the fine particles. They are also called centrifugal or inertial separators. It contains a vertically placed cylinder with an inverted cones attached to the base. When the particulates enter tangentially inside, the centrifugal forces tend to drive the particulates in the wall of the cyclone. The vortex of the cone inside it moves upward after reaching at the bottom of the cylinder. The clear gas is released out from the top of cylinder. On other hand, dust particles are stored at the bottom of the gravity. The efficiency of the cyclone mainly depends upon the cyclone diameter. Its efficiency is inversely proportional to the diameter. Therefore, smaller the diameter, greater is the efficiency. This is due to increase of centrifugal action with decreasing radius of rotation. So, now there are advantages of cyclone method to remove the particulates. First, it has low initial cost for controlling industrial emission. The second, it is simple in operation as well as construction. For construction, it uses those materials which can withstand the temperature and pressure requirements. Third, also it requires low cost for further maintenance. The fourth is the pressure drop of the cylinder used for the removal of particulates is low. And last but not the least, it is involved in continuous disposal of solid particulate matter. The next is electrostatic precipitator. Electrostatic precipitators are particulate collection devices that use electrostatic forces to remove the small particles. The electrostatic precipitators are generally fitted to factories and power stations, chimneys to collect dust that would otherwise escape into the atmosphere to cause pollution. It consists of positively charged electrodes. The maintenance is required for a high potential differences between the two electrodes. Out of these two electrodes, one is discharging electrodes and the other is collecting electrodes. The high potential difference between the electrodes cause a high ionizing field to form. The gases coming out from the factories passes through the negatively charged electrodes become negatively charged. If the gases pass over positively charged electrodes, they get attached to the chimney wall. When they make contact with the electrodes, they become neutralized and may fall into the dust collector space. The collecting space are then shaken to further remove dust particles. As a result, the gases that enters the atmosphere is free of dust. This is a very important and powerful tool and devices. The next is scrubbers. Wet scrubbers are usually used in the case of control of flammable or explosive dust released from industrial and chemical processes. Generally, water is used as scrubber fluid. In this process, the dust particles comes in contact with water droplets and collide with them. Particulate matter is removed by diffusion of the particulate matter on the liquid medium, and the condensation of the liquid medium on the particulate matter helps in increasing the size and weight of the particle and make them easy to remove. And there are many applications of the scrubbers. For example, they are particularly used in case in which the particulate matter is combustible or if any inflammable gas is present. The second thing is scrubbers can be used when there are wastewater treatment systems available on the site. And the third is they are used in the situation when gas reactions and absorption both are simultaneously required with particulate control. There is another important device which is known as fabric filter baghouse. Fabric filtration is one of the most common techniques to collect particulate matter from industrial waste gases. It is based on the principle of filtration, which is a reliable, efficient and economic method to remove particulate matter from the gases. The air pollution control equipment using fabric filters are known as bag houses. A bag house consists of numerous vertically hanging tubular bags which are suspended with their open ends. The number of bags can vary from hundreds to thousands depending upon the size of the bag house. The bags are housed in a shell made up of rigid metal materials. Hoppers are used to store the collected dust temporarily before it is disposed in the landfill. A discharge device is used for emptying the hopper. The gas entering the pipes strikes a plate, which causes larger particulates to fall into the hopper due to gravity. The carrier gas then flows upwards into the tubes and outwards through the fabric, leaving the particulate matter inside the bag.
Control of toxic gases. Control of oxides of sulfur. Sulfur oxides have many undesirable effects on environment. There are many methods to reduce the amount of sulfur oxides released to the atmosphere. Sulfur in organic compounds can be converted into number of compounds by oxidation or reduction. For example, sulfur can be oxidized to sulfur dioxide and further to sulfur trioxide. In the atmosphere, sulfur trioxide reacts with moisture to give sulfuric acid. The most widely used method for control of sulfur oxides is the flue gas desulfurization techniques. The flue gas and fuel desulfurization techniques. In this process, the fuel is burnt in such a way that the sulfur oxides are not emitted to the atmosphere. The process used for this is the catalytic reduction of sulfur dioxide. Sulfur dioxide can be directly converted into elemental sulfur when the gas reacts with carbon monoxide in the presence of a catalyst. Mostly palladium, silver, cobalt, or nickel is used as catalysts. Physicochemical method is also used for controlling sulfur oxides in fuel desulfurization. techniques. This is basically used to remove sulfur from coal before combustion takes place. For the removal of sulfur from coal, it is first subjected to grinding and then hydraulic washing. During the process, inorganic sulfur, being heavier, tends to settle down, and organically bound sulfur in coal is removed by passing hydrogen sulfide gas in the presence of mixed cobalt molybdenum oxide catalyst. The organic sulfur is then converted into hydrogen sulfide, which is then oxidized to sulfur. Then the sulfur may be used as raw material. Control of oxides of nitrogen. Fossil fuel based power plants and automobile exhausts are the main sources of oxides of nitrogen. The oxide of nitrogen can be controlled by two methods. Flue gas treatment. Flue gas treatment can be used to control the oxides of nitrogen. In this process, ammonia is added to flue gas prior to the gas passing over a catalyst. The catalyst enables the ammonia to react chemically with the nitrogen oxides, converting it to molecular nitrogen and water, and 90% of nitrogen oxides removed from the flue gases. Most commonly, metallic platinum is used as a catalyst in this reaction. Fluidized bed combustion. This process suppresses the level of sulfur dioxide from the flue gases after combustion. Limestone is added to the fluidized mixture to reduce the amount of sulfur dioxide emitted in the flue gas. NOxxow technology. It is a modern technology which uses urea to rid flue gases to nitrogen oxides. It involves the injection of aqueous solution of urea in the combustion system. Urea interacts with nitrogen oxides, as a result of which carbon dioxide, nitrogen, and water is formed. It is estimated that about 80% of the nitrogen oxides are removed by noxious technology. Control measures for carbon monoxide. Catalytic burners are used to oxidize toxic carbon monoxide into harmless carbon dioxide gas. The toxic gas has potential to hazard in space flights and submarines. Therefore, in order to reduce the emission of carbon monoxide from vehicles, the automobile companies use catalytic converter. Greenhouse gases. Greenhouse gases are gases which allow the sun radiation to pass through and reach to Earth's surface, and results in global warming. It includes carbon dioxide, methane, nitrous oxide, ozone, chlorofluorocarbons. It affects climate, plants, human health, and wildlife. For restriction in emissions of greenhouse gases, alternative fossil fuels should be used. These energy resources will reduce the emission of harmful oxides of sulfur and nitrogen. Also, the reduction in deforestation by growing more trees is valuable because it would help in preventing drought and improve the soil fertility. Photochemical smog. The main constituent of photochemical smog is from automobile exhaust. Photochemical smog has adverse effects on environment. The three components of photochemical smog are nitrogen oxide, ozone, and organic derivatives. Each contributes to the hazardous effects of the smog. The photochemical smog can be suppressed by the chemical method. Diethyl hydroxylamine is sprayed to the air and generate free radicals which readily combine with free radical of photochemical smog. It suppresses the formation of smog and freshen up the polluted air. This will reduce the production of nitrogen dioxide. Also, catalytic converter can be used in automobiles for reducing smog formation to prevent the release of nitrogen oxide. Control of volatile organic compound. Control and treatment of volatile organic compound and organic hazardous air pollutant emissions are done by the techniques. Adsorption. This is one of the most commonly used methods, especially for controlling emissions from small sources. It can be physical adsorption or chemisorption. Chemisorption is rarely used for the emission control of volatile organic compounds because it involves a less reversible chemical bonding of the pollutant and the adsorbing solid. Physical adsorption uses van der Waals forces. Therefore, the adsorption process is reversible in nature due to the weaker bonding of the gas and the adsorbent material. Activated carbon is a commonly used adsorbent because of its high surface area and material hardness. Then for the regeneration process, generally steam desorption is done. Incineration or combustion method. Incineration or combustion is another common technology. Complete combustion or oxidation of pure hydrocarbons produces carbon dioxide and water. Sulfur and nitrogen compounds produce acid gases, and limited air supply results in the formation of carbon monoxide. Condensation is used to recover gasoline and fuel vapors at gasoline loading terminals and in gasoline dispensing facilities. It is also used in the adsorbent regeneration process to separate solvents from the stream to regenerate the activated carbon.
Now, important thing is there are equipments or instruments which can be used for continuous monitoring? Yes, it is possible. Continuous monitoring instruments are important for the determination of emission factors in atmosphere. Continuous monitoring basically makes use of analytical methods for the determination of the concentration of air pollutants and their effect on the environment. Detailed analysis is also required to determine the emitting rates of air pollutants. The air pollution usually in urban areas is monitored by locating certain number of monitoring stations. The quality of air should be monitored for maintaining health and environment. These instruments are available for the measurements of indoor and outdoor pollution. It helps people to understand the quality of air around them. These instruments include concentration measurement instruments, continuous emission monitoring system, air measuring device, and meteorological instruments. These instruments are used to measure gaseous as well as particulate matter. Now, it can be called as an environmental monitoring, which is used to describe the processes and activities that are used to characterize and monitor air quality of the environment. The monitoring instruments also have some limitations as they require high investment costs, good maintenance, and highly specialized training. Now, the new approach are suggested in order to overcome these difficulties, especially in those countries where investment and maintenance cost for these instruments are major problem. Now you may ask me, what are these different kind of instruments which can be used for continuous monitoring? There are different types of continuous monitoring instruments based on used for continuous measurements of indoor or outdoor pollution. The first is gas second. This is used to monitor gases like H2S, CO2, CH4 or oxygen. The lightweight instruments has highly visible and audible alarms. It has data loggers capability, which is window compatible PC interface, and it is very safe to be used as in hazardous areas. Hazardous gas monitor fatally measures even minute concentration of toxic gases such as chlorine, ammonia, sulfur dioxide and ozone. It has a long sensor life and extremely low cost is required for its maintenance. So the calibration of instrument is simple and it is very easy to monitor. To conclude, it's a very powerful, useful device for environmental monitoring, and it's very economical and long-term data can be stored in such device. The second is carbon dioxide detector. As the name suggests, it is designed to measure the concentration of CO2 or carbon dioxide. It is used in many industries like agriculture, horticulture, nuclear power plants, food processing industries and the beverage industries. This monitoring instrument is compact, lightweight and provided with a quick and easy calibration. So this is also a very important and powerful device for many industries. Another example is CEA gas monitor. CEA gas monitors are used for sensing ammonia, hydrocarbons, ethylene dioxide, hydrogen combustibles, sulfur dioxide, hydrogen sulfides, carbon monoxides and many others. The sensors are highly specific, fast responding and resist to poison. They are not affected by moisture or temperature changes. So this is another device which you can use. To cite another example is control instrument corp. The control instrument corp is used to handle readings from up to 4 different types of sensors. It includes combustible gas, oxygen and toxic gases such as hydrogen sulfides. The device is featured with all alarm and display. So this is also very useful device. There is another device which is known as single point gas monitor, and there are certain features and characteristics of this device. It is a compact, pocket sized, single gas microprocessor controlled monitor and used to continuously detect and display gas concentrations on an easy to read large digital display. It is required for potential gas leak areas. The feature of the monitoring instruments includes that there is a choice of local and remote sensing with this instrument. Don't you think it is interesting? It has flashing LED facilities for warning in any alarming situation. It displays the type of gas and its concentration during detection. It can be monitored up to 2 gases with local or remote sensor. It is designed to detect oxygen deficiency as well as toxic and combustible gases in air, which includes carbon monoxides, hydrogen sulfides, sulfur dioxide, chlorine and chlorine dioxides. Also in this monitoring instrument, a catalytic sensor is used for detecting combustible gases. So this is also a very interesting and powerful device. Another device is multi-gas monitor. The multi-gas monitor instruments have multi-gas sensing technology along with an internal sampling pump. So it has both multi-gas sensing technology along with an internal sampling pump. So this pump is used to provide remote detection facilities in one complete package. So they are basically used for industrial purposes, which include industries like oil, gas, petrochemical, pulp, paper, food, beverage, public utility, municipal waste and heavy industry manufacturing. So diverse industries, they use this kind of monitoring device. So it has many advantages, like for example the features, like first of all the major advantage is, as name suggests, it is used to monitor multi-gas, and other advantage includes automatic zero and automatic span calibration, two alarm levels as per sensor, and a peak alarm.
Single gas fixed monitor. Single gas fixed monitor is a safety area monitor from Unimax. It is used in those area or space where continuous safety verification is needed. It is an effective monitoring instrument for toxic gases like carbon monoxide, ammonia, hydrogen sulfide, sulfur dioxide, nitrogen oxide, nitrogen dioxide, HCN, chlorine. It is also used in determining oxygen levels. Safety Area Monitor provides maximum safety and protection to workers. Some other types of monitoring instruments are emission monitoring. This type of monitoring will be focused on emissions coming out of natural and man-made sources like automobiles and industries. Ambient monitoring. This is used for monitoring the ambient air concentration of toxic as well as non-toxic pollutants. Deposition monitoring. This is used to especially measure the dry and wet deposition of air pollutants. Visibility monitoring. This is primarily used to see atmospheric contaminants for monitoring. Upper air monitoring. This is used to look at ambient concentrations in upper atmosphere with the help of satellites, airplanes, etc. The choice of monitoring instrument used for analysis will depend upon factors such as cost of the monitoring instrument, the air pollutant, and lastly, the environment in which the monitoring equipment is required. There are two types of calibration methods used in air monitoring instruments, that is, static methods and dynamic methods. In static methods, a simple one-point electrical or chemical test is required. On the other hand, dynamic methods are based on generating a flowing stream of calibration gas and then the whole instrument. Continuous emission monitoring instrument. It is historically used to provide the information in industrial areas about combustion control, as the industries are responsible for emission of hazardous gases like carbon monoxide and carbon dioxide. The continuous emission monitoring system is designed by having a sample collector, filter, gas conditioning system, calibration gas system, and a series of gas analyzers. The monitored emissions by these instruments include sulfur dioxide, nitrogen oxides, carbon monoxide, carbon dioxide, hydrogen chloride, airborne particulate matter, mercury, volatile inorganic compounds, and oxygen. The system can also be used to measure airflow and moisture. In monitoring these emissions, the system must be continuously collects, record, and report the required emissions data of air pollutants. In the monitoring process, a small sample of flue gas is extracted by a pump and delivered into the continuous emission monitoring system via a sample collector. Dilution is also done because the pure flue gas can be hot, wet, can stick with any pollutant. The diluted sample is then transported through a sample line to the gas analyzer. The gas analyzers can use various techniques to measure the concentrations of air pollutants. The techniques include infrared and ultraviolet adsorption, chemiluminescence, fluorescence, and beta ray absorption. Continuous emission monitoring system is basically designated to continuously obtain direct emission measurements. This is the most reliable method. Unimax continuous emission monitoring, stack monitoring. It is reliable continuous emission monitoring system. It mainly measures low-level HCl gas and some other gas pollutants such as sulfur dioxide, nitrogen oxide, carbon monoxide, and carbon dioxide. In its mechanism, the dust and moisture from the sample is directly removed directly by the sampling system of the instrument when the sample get extracted from the stack. The obtained dry sample is then transferred to the gas analyzer, in which infrared radiation is utilized with gas filter correlation. Computerized stack sampler. The computerized stack sampling instrument can control the flow of gaseous pollutants so that the sampling is always isokinetic. Sampling can also be performed with a high stack gas, low rates, and heavy filter loading. Combustion gas analyzer. A combustion gas analyzer collects and stores data independently for up to 48 hours. It measures gases like oxygen, carbon monoxide, nitrogen oxides, nitrogen oxide, nitrogen dioxide, sulfur dioxide, RH, and fluorine. It also helps in measuring efficiency, draft, and pressure. There is a new thick film sensor. Its performance is superior to the catalytic bead detectors. It includes some additional features like menu-driven user interface and LCD display. It is also designated with an auto-calibration technique. Combustible gas transmitter. The new infrared combustible gas transmitter requires less maintenance than catalytic bead devices. It has many other advantages, such as there is no risk of positioning in sensor from silicon, halogens, and other contaminants. The high concentration of gases will cause no saturation to sensor. Also, there is no requirement of oxygen for operation. Even if the sensor is continuously exposed to gas, there will be no reductions in sensor life as its response time is faster and it has fewer effects from temperature and humidity. The change in changing weather conditions can result in dramatic changes in air quality and ambient pollution levels. The change in weather conditions are basically dependent upon the factors like rates of wind, dispersion, that is, their velocity as well as their direction, temperature inversions, photochemical reactions, and rain.
Let us now discuss and study the continuous monitoring of organic pollutants. This method is used to measure very low concentration of volatile organic compound in any fluid stream, that is either liquid or gas. The fluid stream passes through an online microsorbent trap, and the pollutants are concentrated or electrically heated for injection into a gas chromatograph system. The pollutants will be separated in the chromatographic column with respect to their pollution level. It is used to accurately measure the low concentration on a continuous basis. So, we can monitor even the organic pollutants on a continuous basis. What are the advantages of monitoring instruments? Air quality monitoring helps us in better understanding the sources of different levels of air pollutants and effects in controlling them. It will also help in understanding the exposure of various substances in the air around us. Monitoring status are used to continuously monitor and collect information about the presence of air pollutants. A typical monitoring station includes systematic analyzer for analyzing gaseous pollutants and their collection. I would like to summarize few things what we have learned so far. The atmosphere is susceptible to pollution from natural sources as well as from human activities that we have to accept. The best way to protect air quality is to reduce the emission of pollutants by changing or improving industrial process. This is the best way. The next thing is, which we have learned, the techniques for controlling air pollutions can be either with or without pollution control equipments. The third thing which we learned is common types of equipments for collecting fine particulates, including cyclones, scrubbers, electrostatic, precipitators, and baghouse filter. The fourth point which I would like to remind is the method for controlling of SOx is the flue gas desulfurization techniques. In this process, the fuel is burned in such a way that the sulfur dioxides are not emitted to the atmosphere. The flue gas treatment is used to control the oxides of nitrogen. In this process, ammonia is added to the flue gas prior to the gas passing over a catalyst. The other pollutant of air pollution are photochemical smog and volatile organic compounds, which can be controlled by several chemical processes like adsorption or combustion. The continuous monitoring instruments basically make to use of analytical methods for the determination of concentration of air pollutants and their effect on environment. These instruments are available for the measurements of both indoor and outdoor air pollution or air pollutants. These instruments like concentration measurement instruments, continuous emission monitoring system, air measuring devices, and metallurgical instruments. The choice of monitoring instruments used for analysis will depend upon the cost of the monitoring instruments and the environment in which the monitoring equipment is required. In continuous emission monitoring, the system must be in continuously collect, record, and report the required emission data of air pollutants. And the last, it is used to accurately measure the low concentration on a continuous basis.